Hi folks, remember that window latch from Fusion Friday 59? Let's machine it today as a Wednesday widget. Folks, this is a pretty tricky part, and this is, I'm excited for the soft jaws and the work holding on this, and some of the Fusion 360 cam. I think this is the coolest, craziest. There's a couple like little trick hacks that we're gonna try out here, and we'll see how it works, but I'm super excited. So welcome to another Wednesday widget. We'll do the usual 1, 2, 3 punch. Let's take a quick look at the Fusion. We're actually gonna finish some of the cam together. We'll cut some stock, we'll machine it up, and then I guess at the end, I'll walk you through what I was thinking, another way to do this, which we didn't use, but that was really some of the coolest Fusion hacks I've thought of, which will be useful, and I would highly encourage you guys to watch. I swear I didn't do this for the video. We actually have a piece of 1/2 inch by 2 inch that we'll cut to 5.5, and I'm gonna plug to our product. So we're gonna use our DeWalt fixture plate, which is great for this kind of work. And the reason we've got this stock is it's what we use to make the top bracket for our Bridgeport power drawbar kits. And if you have a Bridgeport step pulley or variable speed pulley, these are phenomenal. We're now selling them as a assembled unit, including the butterfly impact wrench. Here's our part. So again, so many ways to work hold this and run the setups. Some great comments back in the Fusion Friday we covered on this. And again, at the end of the video, I'll come back and talk about this idea that I had, which was I still like, but we're gonna rock it with soft jaws. So how are we gonna do that? We just cut our stock, which was the 5.5 by 2 by 1/2 inch. So pretty simple. We're gonna go hold that instead of hard jaws, just regular parallels. And we will face it off, do an adaptive with a shear hog, clean it up with a rest strategy, 3D adaptive. And for Patreon folks, we appreciate you supporting our channel. Link in the video description to download this file to play around with it yourself. And then drill that hole and just do an edge break chamfer. So that will leave us, I love this stuff, with that. I call this like the mushroom top, where you've got the part sort of profiled out, but you've got this cap, which when we flip it around, will rest in our soft jaws, the profile of the part will, and we've got to get rid of that cap. So our soft jaws, again, look like this. Actually, if we look at the simulation, we can probably see that even. Let's see here, fast forward. Exactly. So we'll flip it over in op 2. It'll be resting in the soft jaws, and we got to get rid of the top and then finish the part. The soft jaw cam, let's do that, walk through that together. All I've done so far was duplicated this first operation just to create a starting point. So I'll right click, edit. First thing I'm gonna do is flip my Z axis. So click that little arrow, that flips it upward because we're holding it this way now. Z axis, I'll go ahead and pick this stuff even though it's oriented correctly. Oops, flip you again. And X axis will be this. That's all fine. So what's my origin point? Go change it to selected point, and it'll be this point right here. And we'll show when we go to cut the soft jaws, we'll have that same point, and we'll leave them in the machine, which is what the beauty of soft jaws is. I'm locating off of an external point. It's not a point on the part itself. Now, stock is important here. When we flipped it, if I turn my soft jaw visibility off here with this little light bulb, you can see it's got that extra material on the bottom because that's how it sort of was in the first operation, but we flipped the part over, so all that material is now on the top. That's our mushroom cap. Now we don't have the full cubic rectangle of material. It's just the area, you know, up in here. But I still want to make sure I flip that. Let's see here. This all looks good. Okay. So what I'm going to do is shear hog it first, because I don't want to face it with a tool. With that unsupported material. Hold on, let's regenerate all this because it thinks we're still flipped over. There we go. So what I want to do is I want to shear hog, this is kind of weird, from the top of the stock down to the top of the model to get rid of that area. 3D adaptive. Oh, filters you. Shear hog. Heights from stock top to model top. It's kind of weird, right? The bottom of your, oops, move it up to here. it put it in the cutting the soft jaws, which is, it's not taking into account our stock. Not sure why. So let's do stock contours. Just check that. Now it should go all the way around. Now let's just edit some parameters. Looks aggressive. 0.2 and 0.2 I'm fine with. I'll leave no radial, 10 thou axial is fine. Oops. We'll watch a simulation to make sure this looks okay, but that should get rid of my mushroom cap. Now what I can do is go ahead and face it down, which is perfect, and then all I really need to do is get rid of this shelf and then do our edge break. Sweet. So I'll do 2D adaptive, shear hog. My geometry can be, we use 3D adaptive. So we did a Fusion Friday on this, but 3D adaptive takes into account, or does a better job rather of taking into account the solid model, because it's, well, it just does. 3D adaptive basically will machine everything, and then you constrain, subject to the solid model, then you constrain it away. So here it's trying to machine the top and even like the bottom here. So what we'll do is change that to say heights, bottom height is this, top height, I can actually do selection of that as well, because that's all the height area that I want it to work on. Now it needs me to, I have to add a positive offset to this. Just say it's, well, that's where it's allowed to work. There we go. Sorry. You've got to give it some room to link in or lead in here. And then we will do a cleanup, which I'll do as a horizontal. So I'm ready. I'm not going to use this, 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 or this. We will use that edge break chamfer. But first, let's do a 2D contour with our 1/4 inch end mill to clean up that. Okay. I'll stay off the floor 1/2 thou, or 1 thou. And we'll also do a horizontal to clean up that face. So I'll do heights. I want it to basically work from here to there as well, but I'll add a positive 1 thou and a negative 1 thou here. And that should clean up that. On horizontal, I like to leave a little bit of radial stock because I don't want the horizontal to come touch this wall here. Click OK. It should clean up this down here. Perfect. And after we're done with all that, we'll come through and we'll do this edge break chamfer. Okay, let's watch a simulation. So again, this stock isn't totally correct because it's showing that there's a solid chunk of material left. We've obviously removed that from the prior operation. So all we're doing here at first with the shear hog is getting rid of that mushroom cap, cleaning off the top. Now with the Superfly, shear hogging off. Actually, I could do that. I could reorder those because there's no reason to do a tool change there. So roughing that out, clean that up. Horizontal. I usually like to reduce the step over on the horizontal just to make sure I don't leave any nubs or cusps. And chamfer. So the big question is going to be, do our soft jaws work? Let's reorder this real quick. Horizontal. Manual step over. We'll just say 0.21. Sweet. We did some work on the soft jaws. I added some circles because there's no reason to have these really complex, really tight, difficult to machine pieces. We've got so much curvature here that there's not only plenty of locating geometry, but I'm worried there's too much. I don't think I've ever really cut soft jaws with this much complexity. Obviously, the part won't, it can't slide into this one, so it'll have to drop into this back jaw, and then we'll tighten the front moving jaw. You got to think about that, obviously, with the way soft jaws work. But knock on wood, it should work. And to cut the soft jaws, I would recommend downloading the Fusion file to look through this in more detail. But really, it's actually pretty simple. We use our templates, and it's adaptive strategy. Well, kind of on video here, but adaptive strategy with a 1/4 inch, cleaning up rest machining with a 3/16, and then just a little contour to clean this up. We've got them spaced 1/2 inch apart, I believe. Yeah, 1/2 inch apart. So let's go see what happens here, folks. I should have been using smoothing. See those little jerky motions? That's my fault. So if there's one takeaway from this video I want you guys to come away with, it's really understanding stock selection in Fusion 360. That was so critical, both on creating the soft jaws, but also that idea I had to make this part directly on a little one of our our mini pallets that we sell, or any sort of a sacrificial or non-sacrificial fixture plate. Has to do with getting creative about understanding where your toolpaths go and don't go as it relates to what geometry you want to cut, when you will want to avoid clamps, things like that. And there's some, I don't want to call them tricks, but a couple tricks or hacks that we'll go over at the end of the video. We've got a 1/2 inch gauge block in between the jaws, so the movable jaw here is obviously under tension, and we'll leave these in when we go to do the final op. And the reason I do it in this order, obviously we don't have to take our soft jaws out, but also I don't know if these soft jaws are going to work. I don't know if they're going to fit. We normally don't oversize our soft jaw. In other words, we don't make the soft jaw profile any bigger. We sort of cut it both nominally, but this is different because we're going to have to drop this straight down onto it, and that's a little bit weird. So we can test fit our part here before we have to go forward, and we can make some tweaks if need be. Oh, I hope I didn't even think about that. Gliding out the backside. I don't think it's going to. No. Talk about operator error. I didn't even think about the fact that we're going beyond the backside of the soft jaw and thinking about whether that was above the hard jaw or the fixed jaw on that orange vise. Ugh. When I'm doing work like this, I lower my G30 height in PathPilot. It's on your offsets, I think, tab, because there's no reason to have Z come all the way up when you're just trying to bang through a couple tool changes. I don't have the tool changer on this machine. I wish I did, to be honest. I go back and forth on it, but I do like it. And but quick little things like this, keep your Z height low and just hand change tools really fast. Remember we did that 3/16 slotting video? I'll tell you, 3/16 inch tools can take a lot more abuse and heavy tip load than you would think. Or at least I used to think anything below a 1/4 inch was fragile, and that's just not true. Do a real light, I think it's like a 3/1000 edge brake chamfer and we'll give her a test fit. I did turn smoothing on here. Let's see if it does any better on our feed rate. Much better. Look at that. Isn't that amazing? I used to think that smoothing was only a way to reduce your code length to handle the fact that most VMCs that are older than like 10 years have horrendous controllers. They can't handle basic modern adaptive code because the code is so long. Like this line, this code right here is like 4-some thousand lines long, and smoothing helps reduce it. But it actually does it does that, but also that's interesting. Okay, so that's actually great. That tells me the fact that chamfer was way too big tells me I didn't catch that in simulation. We need to stick an 1/8 inch end mill in there and clean that tail up to fit this guy because the 3/16 didn't get in there. Okay, what the heck happened? So the adaptive, go into simulation, turn off, I don't have to do anything, just have it on. If you have the holder that's in your way, just switch it to flute. And if you look, see how I got show points checked? Gives you the little points where you can click on. So I can see, there you go, look at that. I wasn't coming close to finishing that. So a couple things. If I wanted to do more with the adaptive, I could probably decrease the minimum cutting radius. There you go. Change that to 0.5. Should get way tighter in there. Yeah. And look, again, CNC machines don't crash. Operators crash them. Same is true for CAM. CAM puts out great CAM code when you do it correctly. So on my 2D contour cleanup, I didn't do this one, just my mistake. So instead of reposting all of these, I'm going to hit Control D to duplicate it and then edit. I'll delete the other guys and I'll pick that. So we'll repost this and clean that up. All right, I really don't think this is gonna fit. I don't know why. I just have a feeling, which is okay. We'll figure it out. Of course, I dropped my gauge block down in there, but okay. So other than a little bit of flashing like that, that stuff's all okay. Actually, I want to get this movable jaw totally out of the scene for a second because I want to just focus on how does the part fit into the fixed rear jaw. So it is too snug. The tough thing is you can't see. Can't see a darn thing. And I don't want to pull this jaw out. I am going to guess we just need to take -1 thou radial stock around this whole thing, maybe even a little more. I'm going to start walking that in here and just clean this up and just see, baby steps, see one at a time, see if that then will then drop in. This side has a problem too. Let's look at that. Looks like there's just one little point here that's too proud. Can you see that? And so that's no big deal. I think what happened was we didn't, well, I'll go look. But the easy way to do it would be knock that point off. I don't need it at all, per se. So it still doesn't fit. But take a look. When I set it in here, it seems to want to rock. And it acts like there's a pivot point right in here. And that kind of, see how I can kind of go down around it. That kind of jibes with having this tight inside pocket right here. And I don't really need that on the soft jaw. So let's go into Fusion, cut that off a little, and then let's see if it drops in. This idea of hinging ties back to the Richard King scraping class we took and did a video on where we talk about how you read parts and heights and where things are touching and not touching. Model, I always call it CAD. So we're activated on our soft jaws. Let's take C for circle right here, and let's just get rid of that sharp point. So actually here, I'll do L for line. We'll just knock it off. E for extrude, -0.15, and fill it. There and there, 0.05. Okay. If we turn our part back on, and you can see that won't have any locating problems, and hopefully, well, we'll see. Hopefully she drops in. Does she fit? I'm nervous. I don't know why I'm nervous. Who cares? Yeah. Now, actually, if we were smart, we could have Dicom blued that and looked to see where is it rubbing. Ooh, is it right there? Yeah, I think it is. That little corner. Okay, just use Sharpie. You don't need to get Dykem. And let's just see as we push that on, just a little, and boom, that just told us where we're wearing. So let's get rid of that. Where is that? Huh, who would have thought? Little corner right there. I'll be right back. Does she fit? No. Shoot. Man. Let's Sharpie it up here real quick. Sharpie on just about all the what should be contact surfaces. Okay. There we go. Well, that's just... No, you know what? That's good. We're flat, we're square. Yeah, obviously you gotta keep in mind, we could be damaging the OD profile a hair as we're pushing this in, so I don't want to discredit that. We'll see, take a look when it's done, but I think I'm good with that. See how she tightens up. Awesome. Dude, rock solid. Hard work is done. Let's finish her up. So as we shear hog through this, folks, what's awesome about soft jaws is not only do they give us this customized work holding, shape and solution and security and safety and all that, but they establish our work coordinate system. So it's that inside corner of our soft jaw that gives us our XY0, which is so important because there isn't really good geometry on this part to otherwise use. Awesome. Just light clean up on the top of the face. It's really only the arm, obviously. Soft jaws are working great. Knock on aluminum. We pull them off here. We'll take a look. We actually just retrammed this machine in one of our CNC training classes. The guys wanted to see how we tram a Tormach, so we trammed her in. It's actually fun. When you've got that Pro Edge tool, whatever it's called, Edge Tech, makes it easy to see what you're doing, and it can really help improve your cut quality, especially on a superfly. So here we're staying at thou high, but you're still seeing the tool marks because we haven't done the horizontal to deck off that shelf. And on the horizontal, we'll stay slightly off the sidewall. So again, we're focused on the tool cutting only on the floor or the side. And then just tamper it, and we're knock on wood, we're done. I think we're out of the danger zone, which is kind of cool. So would you guys have done this differently? I know in the Fusion Friday comments, somebody said they don't like the cost of soft jaws. And hey, that's fair. I mean, these are 12 bucks a set or so. These are flippable or reversible, so we could use the other side, so you could save $6. And you could even potentially reuse this side depending on the next job you had to do. For me, it's a time thing. That amount of money isn't a huge deal when it comes to my time or when it comes to running these as a job. On the flip side, I will give it to you, semi-sacrificial fixture plates, or like the mini pallet that we sell, card in the video description. It can be great for stuff like this because, hey, I remember buying my first $7 or $8 end mill and thinking, oh my God, this thing has to last forever. I can't afford this stuff. Seriously, that was crazy. How times have changed. Somebody was going back and found one of our New York City Tag Day videos, and it's, to me, it's horrendous, but on the flip side, hopefully it's inspiring to you guys, because again, 10 years ago, I didn't know what a Bridgeport was, I didn't know what an end mill was, I just knew I loved this CNC, I knew I loved watching these machines, shape metal, cut metal, turn and make parts, that's what it's all about. So cool, right? I never thought in a million years I could make a part as complex as this. Camera looks great. Okay, the only thing I don't like is all that raggedy edge there. So I'm going to go post some real light chamfer around the profile here. I'll be right back. It's always at the end where you roll in the parts, right? Now we're using the 2D chamfer op, which detects for collision. So we knock on wood, should be okay. It started, yeah, it looks great. Smoothing again really helps here. We got to do a video on that. I'm impressed. And hopefully we won't crash on that little backside there. Holy cow. We did it. Look, folks, this is not an easy part. I was nervous about this, but if I could do it, you can do it. How awesome is that? I love it. It's so cool. Folks, I hope you learned something. I hope you enjoyed. We really appreciate the folks that support the channel on Patreon. It's as little as $1 a month, and we help. You get access to this. We talk about how we run our business, the chip break stuff. Seriously, go download this, go play with this, go learn, go make parts. Folks, take care. See you next Wednesday.